Okay, we'll get started. In this section, we're going to be going through 5C, which is going to be dealing with the conservation of energy. So the first idea in this section is that energy can be converted from one form to another, that it doesn't have to stay in the same form indefinitely. For example, if you have a light bulb and you leave it on, light bulb, and you leave it on, eventually it's going to become hot. So what's happening is the electrical energy that's powering the light bulb is being converted to thermal energy, is being converted to heat. So that's one example, the energy going from one form to another. Another example would be is if you had a stick of dynamite, and that stick of dynamite were to explode. So you had a stick of dynamite, and then that stick of dynamite were to break into pieces as it exploded. So stick of dynamite explodes into little pieces. So what's happening there is you have chemical potential energy in the chemicals in the dynamite, and that's getting converted to kinetic because those pieces from the explosion are moving. It's also going to get converted to thermal because there's going to be heat released as that stick of dynamite explodes. So that's the idea. That's another example of how energy can get converted from one form into one or more other forms. So there's a specific way we're going to represent this transformation. We're going to use something called energy transformation diagrams. So energy transformation diagrams, it sounds like a big complicated term. It's just a simple kind of picture that we use to show how energy is being converted. So this is one right here, actually. So it shows that, we started with some chemical potential energy, and then that chemical potential energy is getting converted to chemical and also thermal. This is really just showing what happened for that stick of dynamite example. It's representing it with the energy conversion with boxes and arrows. So that's really all it is. So we're going to be using those. And the last idea is just, that it's kind of a simple idea, but it's saying that energy can be transferred also. So a system, you're going to be hearing that term a couple times. A system is a group of objects that's being examined. It could be that light bulb that we looked at. It could be a stick of dynamite. It could be, a bunch of cars on a freeway. Any group of objects, that could be your system, sure. And it's important to realize that energy can be transferred from one system to another. So it can be transferred from one object to another. So let's say we have a coffee cup. All right, not bad. So coffee cup, the thermal energy in the coffee is going to flow to the surrounding air over time. So you're going to get that thermal energy actually going other places. So it's going from the coffee to the air. So that's a real, should be a fairly obvious concept, but just to remind you that energy can physically move from one thing to another. It doesn't have to stay in the same object the whole time. So that's really all the notes. There's kind of a short section, so let's just recap quickly. So energy can be transferred from one object to another. It can also be transferred from one form to another form. And to represent this transformation, we're going to use energy transformation diagrams. So that's really it. Kind of just tying together some loose ends. So let's see an example of how you might look at this conversion of energy. There we go. So it says, diagram the transfer of energy for the following scenario. A ball is dropped and bounces off the ground to its original height. So take a second to see if you can solve it out. If you're having difficulty, I would recommend drawing a picture first, and then before you try to actually diagram out what's happening. So make sure you have something. You should very least have a picture of what's going on. Okay, I'm going to go through. So what do we have? We have a ball that's dropped. So ball dropped. So it's going to be not moving, and then it'll pick up some speed, and then it'll hit the ground. Then it says it bounces back up. So what's going to happen is it's going to gain some velocity upward, and then it's going to be at its original height again, and it's actually going to be stopped at that original height. So really this is what's happening. So it's asking us to diagram really what's happening. What are the different types of energy? So we're going to have to look at the types of energy that are, how the energy is being transferred through this whole thing. So the first thing, when we're up here, when we're originally being dropped, it's technically not moving. It's going to start moving very quickly, but it's just raised to some height off the ground, so it's just going to have UG. So it's going to have some gravitational potential energy because it's raised off the ground some amount. And then as it falls, that gravitational potential energy is going to be converted to motion, to making the ball move. So it's going to get converted to kinetic energy, and the symbol is K. Then it's going to hit the ground down here, and what's going to happen is it's going to get squished, right? All that energy from the motion is actually going to squish the ball, and it says it bounces, so that energy is really being stored in the ball because it's kind of springy. So that kinetic energy is going to go to potential elastic energy, UE, right? The energy that's stored in the springiness of the ball. And then what happens after that is that energy gets released and it bounces back up. It's going to have some kinetic on the way up. Kinetic. And then the last thing that's going to happen is once it reaches its original height, technically it's not moving once it reaches its original height. So it bounces back, going to reach its original height. It's actually stopping in the air for a couple seconds. Or not a couple seconds, like a split second it'll be in the air, it won't be moving, so it'll just have gravitational potential energy. Then after that, we predict it's going to fall again and continuing, but that's what the problem's talking about. So yeah, not too bad of a problem. It's really just focusing, are you clear what's physically happening, and then are you clear the types of energy that it possesses at each point and how they're going from one type to another. So that's about it. This is a shorter section, so make sure you have the notes, make sure you have the problem all copied down correctly, and that's it for now.